So in this video, I'm going to be explaining this configuration of the Intel Max 10 FPGA to implement a shift register program. This is crucial for future in digital systems for shifting and storing data bits. To navigate through this complex task, meticulous adherence to compensate tutorial was essential, offering detailed guidance at every step. So first of all, I'm going to be dividing this code in blocks of code so you have a better conversation of this register. So first of all, these are the libraries. So these libraries are necessary to define the entity, shiftreg. The entity has 4 ports, as you can see. So this is the clock of 50 MHz, the main clock input, the reset as the reset input, and the clock out as the clock output. Also, we have the reg as the shift register output. Now, these are the architecture. So we are using the behavioral architecture of the shift reg. So this defines the behavior of the logic register, and it has these parts. It has the internal signals, with the clock temp. This is 26-bit vector used to divide the frequency of this input clock to approximately 1.9 MHz or 50 MHz divided to 26. Now we have the clock new. This is an alias for the bit 22 for the clock temp vector, which is used as the clock signal of the shift register. So basically, if I put this like 2, I can make a better simulation of how this program will work. But in essential, if we want to check this code in real life with this FPGA, you will need to put a higher number like 22, 23, 24, and maximum 25. So the bigger the number, the slower will be. The lower the number, the faster it will be. Now, also we have the shift temp. This is a 8-bit vector that stores the shifting bit sequence, and the FWD that is a bit controlling the direction of the shifting forward or backward. So in this case is 1, as you can see. Now I'm going to be explaining the block of begin. So first of all, clock divider. This is a process that triggers on each rising edge of clock of 50 MHz or when the reset is high. It divides the frequency of the input clock of 50 MHz by generating a new clock of pulse clock new approximately every 26 pulse of input clock. Now, within this has the shift register process. This process is triggered on each rising edge of clock new. So if shifts the bits in shift temp either left or right based on the value of the FWD. When FWD is high, it shifts right, and when FW is low, it shifts left. The shifting direction changes when the shift temp reaches either X40 or X2, indicating the end of the points of shifting operation. So it might be complex to understand all this, but I hope you understand it with a better view when I show you this in the FPGA. Now I'm gonna be explaining the BHT. This is only for simulation processes. So this is all auto-generated by Quartus Prime Lead Edition. The only part that we are gonna be changing is this part of begin, that is code executes for every event on sensitivity list. So as you can see, this is a loop. It will be happening once every every 10 nanoseconds. It will change from 0 to 1, as you can see. So if the clock loop of 50 megahertz is 0, it will wait for 10 nanoseconds. If the clock of 50 megahertz is 1, it will wait for 10 nanoseconds, as you can see. So the shift register component is initialized with the name 1. Connections between the ports of the shift register module and the signals of the attachment are established. So these all components are displaying the connections between the ports of the shift register module and the signals of the attach bench, as you can see. Now, the initialization process. The init process is defined which contains a single wait statement. This process is instead of initialization purposes. And the clock generation process always. The always process generator is from 50 MHz clock, and the signal is clock 50 MHz is the name that is displaying this action. It toggles the clock signal between 0 and 1 every 10 nanoseconds in an infinite loop. So it's everything for this video. I hope you learned something from this, and see you in the next one.
Hello, welcome back. So, as you remember, we are in the FPGA University program, and now I'm gonna be explaining the physical part of this code that if you remember well, is a shift register. So the switches are turning on and off in line from the first switch to the final. So if I pull up the first switch, as you can see, it will stop. So and make sure to check this out. I will pull it up right now. So every time I pull this up, it will stop in the final LED. So this is how this works. I hope you learned something from this tutorial, and see you in the next one.